is episode 26, and Commander Banban says hi to everyone. It is yet another Trino community broadcast. Myself, Manfred Moser, and Brian Olsen are joined today by Mark Rover, and we'll talk about all sorts of cool stuff, including the upcoming release that's just about the corner, slipping across the finish line, hopefully later this week. We'll talk about Amundsen. All right, I have to get my Norwegian dialect going better there. We'll also talk about STEM AI and lots of interesting things. So how's it going? I'm looking forward to this, Brian.
Yeah, going pretty well. I was up late last night kind of cramming in the notes for this, but we got it just across the finish line, and I'm really excited to cover the demo for this today. This has been a project that I've been looking at for some time, kind of lurking on their Slack channel and seeing all the awesome work that Mark's been doing with this. And so I've been trying to get, an excuse to basically get my hands dirty and play around with the code a little bit. So I got that chance, and I'll be sharing that with you a little bit. Also just about, kind of some of the ways that you can contribute to not only Amundsen, but kind of the Trino aspects of this project as well. So lots to look forward to. And then we're going to hear, obviously, straight from the horse's mouth what this is all about. So thanks, Mark, for joining us, and welcome.
Thank you. I'm super glad to be here to share a little more about myself. I am Mark Grover. I am the co-creator of the Amundsen project. We'll talk about that, like you said, a lot today. And I'm the CEO and co-founder of Stemma, which provides a managed version of the same. So excited to be here. Thank you for having me.
Yeah. What are the common pronunciations that you hear? Let's go over the wrong ways first.
Yeah. Well, so the name comes from this Norwegian explorer, and the reason why this name was put on the project because this project is a data discovery project. Yeah. And the idea is that you can explore the data within a company, establish trust really quickly. And this data could be stored in various different systems, including Trino, right? So like you've got so much data and you want to figure out what's trustworthy in here.
Yeah.
And we had the session around naming, which was an internal, this was created at Lyft, and we had an internal, like maybe 5-6 members of the team got together. We were like, what should we name this thing? Data catalog or data discovery tool doesn't sound like the right thing.
Yeah.
And we had one person, Beto, who had worked in geography, genealogy.
Beto was on a previous show. We had Preset on here a while back.
Oh, really? Okay, yeah. Same guy. So Beto has worked in geography before in Brazil, and he was like, oh, I have the right guy. So if you want to choose like an explorer name, there's this Norwegian person who was the first person to visit South Pole, and therefore the first person to visit both poles. And we're like, whoa, that's cool, let's do this. And that name was Roald Amundsen, right? And so but obviously none of us were Norwegian, we didn't know how to say it. So apparently like the right way to say it is Amundsen. And the first way we started saying this was Amundsen, which is a very like plain, mellow way. And now,
I say it.
And now that's changed to Amundsen. It's like another common way, which is how people refer to. That's also, I have changed my pronunciation to that way now. I say Amundsen, which is still not the Norwegian. I think one day we will probably get to a point where we are all saying Amundsen.
Yeah.
But we aren't there yet.
Get a Norwegian,
I'm not even going to ask you about the first name of that guy.
Yeah.
We need to get like a Norwegian spokesman that can just like say it correctly enough times and get it out there in the public so that we all start thinking about it the right way.
Yeah.
Cool. Well, before we hop into all of that, let's do a quick announcement or show from the sponsors from Starburst.
I'm Colleen Tarto. I am the Director of Engineering on Starburst Galaxy.
What is it actually offering? So, I mean, I think this kind of like builds on some of the open source Trino stuff, but is it doing a lot more? What kind of pains is it solving? Could you kind of give us a little bit of insight on what actual pain this is going to be alleviating?
Yeah, absolutely. And so to think about that, I always like to go back and think about what's the difference between Starburst Enterprise and Trino, right? And so I always like to think of Starburst Enterprise as the cool older sibling to Trino. It's a little bit more mature, a little cooler. It's got a car. It's got some cool stuff going on, leather jacket, And Trino is awesome in its own right, don't get me wrong, but Starburst Enterprise is just better and a bit more grown up. And specifically what that means to me is that with Enterprise, you get more functionality faster performance, more connectors, more security, better management, better integration into the ecosystem of tools that you already use today, data governance, integration, et cetera, et cetera. But what really speaks volumes to me is that when you use Starburst Enterprise, you get Starburst, right? You get best-in-class support from the folks who work for us, and they know Trino best because they created Trino, and they're continuing to contribute to Trino. But Starburst Galaxy takes that to a whole nother level, right? So one of the pain points is installing, managing, maintaining, monitoring Starburst Enterprise. And so Starburst Galaxy alleviates all of that, right? So it's a fully managed service. It's Starburst Enterprise as a managed service and more.
And one last question, is there going to be any free offerings coming up anytime soon? Is that on the road?
Absolutely. We're building out, we've got a free trial. So if you're interested, absolutely reach out to us. We are very excited about it. And then we're talking about sort of a free tier. So like being able to just play around with it in your own environment and see what's what.
We'll keep you all up to date on when you can start to play around with Galaxy and Trino for free for just a little bit and get to know this incredible service called Starburst Galaxy. Thank you so much, Colleen.
Thank you.
All right. Well, we haven't quite made it across the finish line with 362 yet, but Manfred, do you have anything in terms of like what cool aspects that you can kind of give us some sneak peeks coming up?
So it's literally super close. Like, you know how the development process works is that all the code gets merged constantly, reviews and all that sort of heavy lifting happens. And then towards the end, we call for a release and we put together the release notes and rigmarole that and make sure that they like, you know, all the I's are dotted and the T's are crossed. And that's the phase we're in. So, and that has been going on for like 2 or 3 days already now. So literally, I'm thinking the binaries might end up shipping today or tomorrow. So we'll see. But that's, of course, I already know what's in there because I can look at the pull request where they're writing the release notes. So I snuck into and found out a bit more. So what's happening is Marius, our ex-guest from Vienna, got a new list aggregation function contributed, which is pretty cool. So the race between you and him and contributing more code is on, I think.
I think he's winning for sure.
Well, I mean, we have to do this broadcast and all sorts of other cool stuff. Well, we'll talk about it later. There's always more coming, right?
Yes.
Join performance got again improved, and also queries that have a distinct statement in it got improved. There are a couple of changes on the SQL security when you use alter schema as a statement. And then for the create, drop, update, and whatever role statement, we added an in table. So that made it a bit more clear where you're creating that role or whatever. So all around a bit SQL security basic improvements. And just to keep in mind, with that related to, we also documented sort of all the connectors that support what specific SQL statements they support. That's now up to date. And when it comes to SQL security, it's literally the Hive connector that supports that. So it really mostly applies to that. There were a whole bunch of changes coming into the BigQuery connector. If you use that connector, definitely check that out. Should be some interesting things. And then, as always, the performance improvements and correctness improvements are also happening on our big fat Hive connector that does everything. This time, we improved the Parquet file reading a bit more. So that's been really useful as well, right? So org and Parquet are getting really kind of both really, really good in terms of performance and correctness and stuff like that. And obviously, those are the column formats files that you probably want to use. You don't want to go with JSON or something string-based that's a bit slower.
Oh, no. That's going to take you forever, and you're going to be like, why is Trino performing like a snail?
Yeah, exactly. It's because your files are big fat strings. You have to parse those. But yeah, that's what's happening. Stay tuned for that.
Point. Isn't that your team right there, putting these SQL support sections?
Yeah, that's my team. So we've been ripping into it, and it's been very interesting because we also find issues and bugs with that. We're like, so you're saying this works, but this doesn't, and so there's a couple of things like, you know, we have this new section in the docs that talks about sort of view management and materialized view management and SQL security, right? And what's part of it. And there's some things where it's like, well, it doesn't make sense if you can create a table but then not drop the table, or you can create it and drop it but you can't alter it, right? So there's a couple of things where we'll hopefully over the future go forward and improve the connectors to be really consistent, that if it can do table management, that includes altering the table, not just creating and dropping it, for example. And then our next project, we already have more projects up our sleeve. Of course, we're documenting push down, like, dereference push down, column projection push down, and all these things. And there we're also going to go and document in the connectors which ones actually support all that. So
and these are a source of a huge amount of the questions that we see on Slack too. All of this stuff about how does this push down work in this connector versus that connector. That's going to be like a huge time saver for us on the Slack side, which obviously we don't mind to do, but it'll be just so much better to have that just right there out there in the documentation. So nobody has to waste their time asking questions or answering questions anymore about that. So that's fantastic. I also saw that create, drop, and roll, and I immediately just thought stop, drop, and roll.
And hide under the table and in a door frame and so on. That's not an SQL statement, by the way.
If you're ever on fire, just think of in table.
And now that we got that done, we can climb out from under the table and talk about data discovery and Amundsen.
All right, why don't we go ahead and move on to the concept of the week. All right, I'm too zoomed in now. Hold on. We'll get this working. Oh no! There we go. There we are. All right. It's still taking. I don't know why. I feel like, is it streaming like super delayed for you guys as well?
A little bit. You're just too fast and hoppy.
I know. Apparently,
it's beautiful now. Don't worry. It's good.
Wonderful.
So concept of the week is data discovery and Amundsen. So let's see what you can tell us.
Yeah, Mark, what? So if you were to just like take your definition of like data discovery, I put a very long, convoluted in prose, how I would kind of talk about data discovery. But you are the expert as you developed a product around this. So what would you say, if you were to talk about just data discovery as a concept, how would you tell somebody on the street about this?
Yeah, totally. And before I get there, I want to share with you like how we got here, like why did this become a problem in the first place? So what's happened over the last 10 years is that we've made a lot of investment in bringing data into the organization. So there's things like Kafka, there's Stitch, Fivetran that let you like get more data into the company.
Yep.
And then there's technologies like Trino that help you store, process this data and access it through SQL and other means.
Yep.
Then there are consumption tools that like let analysts, data scientists, product managers use this data in data warehouses directly. So you've got Tableau, Looker, Moat, things of that nature. Yep. And then we've created a culture of hunger for data-driven decisions, right? So what you've got is you've got some tooling for analyzing this data. You've got tools, you got people in most cases like who are hungry for using this data. And the problem is because there's so much data, there's no good sense for a person who's trying to make a decision with data as to what data is trustworthy. And that problem is the problem of data discovery. So data discovery is the act of finding trustworthy data that I can use for my analysis, decision-making, machine learning model by relying on automated means of metadata which already exists in the system. These automated means are who else is using it, how many dashboards are built on top of it, when was it last updated, what are the various statistics around this data set, so on and so forth. So to me, that's the definition of this problem.
Cool. And so you started to kind of run into this a little bit. Could you just give us like the backstory? So you already kind of mentioned a little before, you were mentioning people at Lyft, you and Beto, coming up with Explorer names. What were the kind of criteria and the problems that arose? I'll mention that we talked about this. Me and Paco Nathan a couple months back were talking about your project in particular because we were talking about the same thing. Like Trino is this wonderful tool that seems to solve like so many problems from an engineering standpoint, data engineering standpoint. But then you know, once you actually expose that endpoint to somebody, then what do they do with that? And so that's been a question that's been on my mind even before, like when I was using Trino in a previous company, and I was just like, okay, you know, like I don't know how to share this with everybody except for, you know, documenting a whole bunch of stuff on a wiki, right?
Yeah.
So then, you know, I brought this up to Paco, and he's just like, you know, yeah, you know, there's a lot of stuff coming down the line with this. You know, this guy named Mark Grover's doing all this crazy stuff at Lyft. So could you tell us about the backstory there and what you guys came into that?
Yeah, totally. Paco's phenomenal. I'll tell you this one story that is that's just like buried in my head very viscerally.
Okay.
I used to work at Cloudera, where I worked on Spark and Hive. And was a member of a bunch of open source communities as an engineer. And then after that, I moved to Lyft, and Lyft was an organization that was all on the cloud. So there was no on-premise software. And it was mostly consolidated in terms of their data warehousing. And I started spending time with analytics, data science users to just understand what their day-to-day work looked like. And I remember sitting down with an analyst who worked in the ETA team. Now, ETA is the time a Lyft driver takes to get to you to pick you up when you request your ride, right? Yeah. But if you're taking a Lyft app, you open the app, I tell you, hey, Brian, your ETA, your driver's ETA is like 4 minutes, right? And then there's a funnel. You choose like your ride type. You then like maybe put in your destination depending on what version of the app you're using. And then there's the actual time when the driver gets to you. That may be 10 minutes, right?
Yeah.
So when someone asked, like this data scientist was actually working on a project to improve Lyft ride ETAs for drivers. And they were trying to find the source of truth for ETA data in the warehouse. So they could compare their new ETA predictions with the old ones and see how much improvement they've had, right? Yeah. But a simple question, and also, by the way, like if you work for a ride sharing company, there are really two product metrics that matter the most. It's ETA and it's pricing, right? Yeah. And so ETA being one of those top two, like you would imagine finding the source of truth for ETA data would be easy. It'd be like known everywhere. Everybody could be woken up at 3 a.m, be like, tell me what table or column has ETAs. And
right there.
Yeah, right there, right? But the problem is that we measure ETA like 5 times in every session, right? Because like when you open the app, that's one ETA. You go to the funnel, there's a different ETA being recorded. There are models that produce ETAs, but some models were running in the past that have logged data in the warehouse, but are no longer being populated further. And lastly, sometimes you run algorithms and models that run side by side. So there's one that's showing ETA to Manfred at any given time, and the other one that's running in shadow mode and not really showing the ETA to the user, but logging this ETA for testing or like next version purposes, right? Yeah. So if you look at any warehouse and you search for anything related to ETA, any column name that has something to do with ETA, you get like 200 entries, right?
Yeah.
And the canonical way to solve this problem has been through like certification. That Manfred, you work in the ETA team. Thou shall have this volunteer duty on top of your existing responsibilities to badge a column that is a source of truth for ETA data and keep it up to date. The problem with modern organizations is that there's so much data, and this data is evolving so fast that no one person, not even a team of people, can keep up to date with this stuff, right?
So you're crowdsourcing it in a way, aren't you?
I'm sorry?
You kind of crowdsourcing the like to some degree, even like a voting, and then you're gathering all that data.
Yeah.
Cool.
Yeah.
Where's the source? You know, the same way it's hard to find the source of truth of the actual data itself, but where's the source of truth about the data, right? Like where's the one place that you go to? You know, I remember in my last org, it was Wikidocs, right? We did Wikidocs, but every team had a different process in how they documented their what their source of truth was, and nobody got onto a common standard about how this data got exposed. Everybody, you know, some people use these like giant CSV files. The people like just had, you know, kind of their random drop downs. A lot of teams fail to maintain them because it just wasn't that important. And so, you know, depending on which team. And so you get mixed results whenever you start searching around in this wiki space, and you kind of have to keep bugging the teams like, hey, who owns this? And sometimes nobody even knew, you know?
Yeah. And so there's definitely a complex human problem to this. But what I found was in the 200 or so columns that were related to ETA, you could easily rule out 180 of them just based on some automated signals, right? Yeah. So the things that, for example, that haven't been updated since last month, they are not the actual source of truth because they haven't been updated, right? Yeah. Things that have dashboards built on top of it. There's an executive dashboard that's powered by the ETA column. That's a pretty good signal for you to consider, right? If no other, if the only report that used a particular column was in a person's personal repository, that's another really good signal. So the real question became, can I use all these signals that are coming from my data warehousing system, my HR system around Teams, my dashboarding system, and my orchestration system to then power a view of the world where I'm not maybe telling you what is absolutely the single source of truth, like with a guarantee, but I could say like this space of 200, I've reduced it down to 10, and I can even order these 10, and then you go, very quickly can figure out what is the source of truth. So that's the direction that I took at Lyft, and that the community and the project have continued to take.
Very cool. Yeah, and you mentioned on the or the community mentions in the documentation too. You call it a page rank, and so you kind of just those signals that you have kind of go in. You essentially could treat those as like kind of the links. Like the fact that this BI tool or this dashboard is pointing to this data set, or a number of them are pointing to this one data set. That's like essentially in the page rank algorithm. That's like a link pointing to that, right? And so you're basically giving it more power. The more things that use it, the more frequently it gets used. Is essentially one point up to say, it's this much more popular. It's essentially increasing the SEO value of that.
And we actually weight different kinds of usage differently as well. So if a programmatic usage, sometimes you can schedule a query in a BI tool and runs every day at 9 a.m. or whatever. That gets one score. But if you ad hoc run a query, like you go to, some BI tool and run this query, then that score by default, by the way, is like 10 times higher weight than a scheduled query. And so we do a bunch of these weights as well in the PageRank algorithm.
Gotcha. And is that customizable? Because like maybe depending on the org, right? That might be different on how they work.
Absolutely, it's customizable. I think the long term there is to actually to have these weights not be static, but they be dynamic, which is what linear regression or ML will help us with, but we aren't there yet.
Yeah, no. Yeah, it is. How old is Amundsen as an open source project? I'm kind of curious.
The project was started about 3.5 years ago internally, and then open sourced like 6 months later. Okay. We were in open source stealth where you put the code on GitHub, but you don't really talk about it for another 6 months or so.
Nice.
And then we started talking about it through conferences. I wrote a blog post. Another member of the Amundsen team, Tao, wrote a blog post, and that kind of like pushed us to then do more conferences and talks and grew the community. The community is now over 2,000 people.
Nice.
It has more than 35 companies using it. So the companies that use Amundsen are Lyft, obviously, where it was created, but Square, ING, Workday, Brex, Asana. The list goes on, iRobot, and so on and so forth.
Cool. That's awesome. So, get me wrong, if I'm getting this right, you essentially gathering a lot of data into Amundsen, and then you do analysis, and you have your own like metadata storage and weighting and ranking and all that sort of stuff. Is that kind of like correct?
Absolutely, yeah.
So how do you manage all that data, and where do you store it?
Yeah, Brian's got the answer.
I'll let you talk about it. I just wanted to pull it up, and I actually wanted to point out that I fixed your architecture here. I think there was something a little off with one of the data sources, but
Thank you for fixing that.
So could you walk us kind of through the different parts of this, and how, from a technical standpoint, how does it work?
Yeah, it's also funny as I walk this through. For engineers, I walk this diagram top to bottom. But for users like a data scientist or an analyst, I'll walk the diagram bottom up.
Funny, yeah.
And Well, so in this case, I'll do top to bottom.
Great.
And,
I think that's a target audience here.
Yeah.
Are you sure? I'm like, microservices front end. Let's see what that does.
Yeah. So, like y'all said, like the one thing we do is we gather metadata from a bunch of different sources. There are a few key sources we gather them from. So, the first key source is a data warehouse, something like Trino. And the things we want to gather here are information schema like metadata, as well as logs, because these logs are then parsed to generate lineage, to generate various other metadata around who the frequent users are, so on and so forth. The second category of systems we get metadata from are your dashboarding systems. So these are your Tableau, Looker, Mode, things of that nature. And we get information from their APIs on what dashboards exist, what tables are being used to build those dashboards, who are using them, how many times those dashboards get viewed, so on and so forth. A third category of systems we get information from are orchestration systems. So we had the first integration with Airflow, where we would get information around what DAG generated what table, when was this table last updated, so on and so forth. And that comes from Airflow. And then there's a long tail, I would say, of integrations here. So there's an integration with HR systems. So often we can use information around team structure. And then if Manfred and I are on the same team, and I'm joining Manfred's team, like I could look up what data sets does Manfred use. Like in the future, we could push data sets to me that Manfred uses, so on and so forth. So that's like a larger category. There's a few other examples here. Some companies want to associate GitHub files that have the code that's used to generate the table also with there. But I'll just stop here. So that's like the kind of categories of systems we integrate with.
Cool.
Then we have an internal ingestion framework, which is called Data Builder, that ingests this stuff into two data stores. The first one is a Neo4j database, which is a graph database. That's how it started, but we've since then added support for Atlas. So there are companies that are already on Atlas that would want to pull in additional metadata in Neo4j and power some of the downstream services that I'm going to talk about in a moment on top of Atlas instead of Neo4j. We've added
just to jump in. Atlas is the hosted version of MongoDB.
Right. That name is so commonly used that it is not that's not the Atlas I'm referring to.
So that's why I was asking. So which Atlas are you talking about then?
Yeah, I'm referring to Apache Atlas, which is a Hadoop ecosystem data catalog, data governance project.
All right, cool. All right, good. So that's good to understand.
Yeah,
so that's an Apache license software then. Okay.
Yeah, that's right. And so the other sort of stores we have added that replace Neo4j are relational databases. And WePay was a company that was pretty interested in not having to manage their own graph database. So they added support for a relational database. And then we added support for AWS Neptune as a graph store. And SeatGeek was the company that wanted just to manage that. Anyway, that's all to say there's a graph database where we pull this stuff, and this is the core of all this metadata. This is where you have relationships between tables and columns with other columns, DAGs with tables, people with tables, dashboard with tables. You get the idea. Mm-hmm. On the other side, we have Elasticsearch. Now this powers our search interface, and this is where all the weights we were discussing earlier all go. And the sort of source of all the search and page ranking is here, right? On top of, or on the bottom in this diagram, but on top of these storage systems are these services that enable other actual useful services, like a front-end service that powers a UI, or an application that's generating some data. I'll talk about those in a moment. These services expose endpoints for other services to query. The idea here is that you could use them for a variety of different use cases, not just the front-end application. The most common use is the front-end application. So it's kind of like a Google search system. It's the most common way how people use Amundsen, which is being able to query some data and say like, hey, I'm looking for COVID cases data. Where does it contain? It comes with a search rank order. You go to the table page and you see all information about when was the last updated, who owns it, what dashboards are built on top of it, so on and so forth.
Oh, that's really interesting. So Amundsen, so you were mentioning Elasticsearch, you were mentioning Neo4j, and then we talked about Atlas. All of these are using different open source licenses. So I'm like confused now. So what what license is Amundsen using, and like is that easily like redistributable and usable?
Yeah, Amundsen uses Apache V2.
Okay, cool.
Nice.
Yeah, and we are part of the Linux Foundation. LFAI is the sub foundation we're a part of,
Okay.
and that and so all our licenses are Apache compatible that we use.
Very cool.
Cool. The last thing I want to mention around other microservices, which is like the big reveal that happened for me, was I was building this data discovery product that would help analysts, data scientists, data engineers become more effective with data very quickly. So you could operationalize changes, data migration, so on and so forth very quickly for data engineers. And you could quickly understand what data to use as a data scientist, data analyst. But what I found is in late 2019 is that California came up with this regulation, CCPA, right? And it was the GDPR equivalent of California. And a bunch of metadata that we had collected as a part of this ecosystem was the same metadata that was used, that was needed for complying with CCPA, right? And this metadata allowed us to know what data was in our systems, who was using it, and so on and so forth. And so this other services part is the part where one company in particular, Square, in the open source community, pushed Amundsen in their direction. And that's the beauty of open source projects, is that you as a contributor can push it in whichever way you want to take it, right? So what Square did was they used Google DLP and sent samples of their data to DLP to then classify data as PII, NPI, PHI, so on and so forth, and then brought those tags back into Amundsen. Then Amundsen was then used to audit whether certain systems should have PII or not. And if it wasn't supposed to have PII, they would have alerting based on it. So Amundsen became the source of truth around information around classification and what was in the warehouse, helping solve for privacy and other regulatory needs. And that was a great reveal that happened as we were working on the project.
So the metadata service kind of acts as a bit of an API, essentially.
Right. Yeah. Exactly. Yep.
That's awesome. That's cool. That's great. That's a good sign when an open source project sort of like gets picked up and you find out that people use it for stuff that you didn't think of the first place, or like expands the horizon where it was planned for. That's a great sign. So awesome.
And that's really a big part of the point, right? Like you're ultimately trying to source out not only just like, sharing your code and getting, people to contribute their code back in to like solve the original use case, but it's actually about like getting other people's use cases, right? And trying to make the product more resilient and more, all encompassing. So I think that's the hope and the desire for any open source project for sure. So can you talk to us a little bit now that we've kind of gone the higher level? Let's zoom in a little bit. I want to zoom in on data. So when most engineers that want to interact with Amundsen or whatever, I got to say it the plain way. When anybody wants to interact with Amundsen and they want to basically pull data out, sometimes they're going to be able to kind of find some of the examples that we have kind of already listed in there that you have, and that's a good starting point. You'll probably want to kind of figure out what how those examples are set up, and I was doing that literally the last couple of days, and so you all have a framework in place to kind of facilitate the ETL processes that go from taking that information schema and all that metadata out and pulling it into the Elasticsearch and Neo4j data stores. So that's called the data builder. And so it looks like there's kind of a bit of a process to that. So you want to talk about that and kind of talk about the main like job, task, and ETL pieces that go into that that engineers will have to set up themselves when they want us to do this.
Yeah, absolutely. So it's like the at the logical level, it is any other ETL tool. So there's I actually can't read your screen, so let me expand this. There we go. Yeah, extract, transform, loader, and then after that is a publisher. So the way that this works is, by the way, like we have a variety of different connectors. There's I haven't counted, but there's over maybe 20, 30 connectors, something like that.
Yeah,
I should have a count at the top of my head. So there's cases in which you have a connector that's already doing this for you. All you had to do is plug in your configuration, and then this just happens, right? And then there are cases when you have to build your own connector. So in the first case, an extractor, transformer, loader, or publisher has already been written for you. And your extractor will take in a configuration around, what is my Trino or Hive Metastore access point? What are the creds for that? And in some cases, it would take another access point around, like for a dashboard connector, you would find it asking for API keys to a dashboarding system, so on and so forth. The transform is a thing in the middle which allows you to transform some metadata along the way. This is used for cleaning as well as any slight transformations that you may want to do. And then what we use for better or worse is CSV files that we end up dumping out of this ETL task and then loading into Neo4j. So that's what happens in the loader and the publisher part. And it's just creating these CSV files that get uploaded.
Could you talk a little bit about, that was one of the things that just getting into this, when I was looking at these, I read the definition. It talked about something to do with like an asynchronous something or other, but could you just talk a little bit about the difference between the loader and the publisher? Because I was able to get around to getting all this working with just an extractor and loader, right? So if you're just trying to get the bare minimum and just testing things out, those are like the two totally necessary pieces. But I'm kind of curious to know about the cases. Like, I think the transformer makes sense, but like, when would you want to use a publisher specifically and not just a loader?
Yeah. So that happens when you're like, it's more relevant when you're trying to publish data to another non-Neo4j system, right? Like you're trying to publish to Neptune or another system.
Okay.
It also, the things that we've also tried is like, in addition to Neo4j, you have to publish it to Elasticsearch as well. And right now there's like a little bit of a hop going from Neo4j to Elasticsearch, but like if there was to go at the same time, that's the place where we would use that for. I think these are, but most of the time you're just taking a standard configuration. We have great examples on how what you need to do to configure this, and you just plug in your appropriate values and run a data builder job. The thing to keep in mind about data builder is that it's a library, which means you run it like a script, and then and that gets data ingested. But in any production deploy, you would have to orchestrate this library. So you would have to then use data builder with Airflow or something like that.
Which, and I also noticed that there's some DAGs like readily available kind of examples as well. So yeah, so if you're using Airflow already, there's already DAGs that you all provide, and as really nice examples too.
Yep.
Cool. Cool. Let's go. I wanted to hop in and just showcase, so we've been already talking about this a little bit. And let me see if I can zoom out just a smidge. So here's the kind of model, and this is very, graphy and Neo4j style, right? So yeah, this is, I'm guessing, like really what stores everything that we end up seeing on the UI, and Neo4j's documents. So I'm guessing like this is what the model is. You store it in Neo4j, and then you just kind of duplicate over for a search capability. You duplicate those documents over from Neo4j into an Elasticsearch index or something, and then you're able to search on those. But ultimately, Neo4j is the one that's kind of holding the core model of the data, right?
Yeah. Absolutely right. And then this diagram hasn't been updated though. So for example, there are dashboards in this diagram now that don't appear. You can have ML features now in Amundsen, so you can discover what features exist in my organization, just the way you could discover tables. And we have integration with things like Feast for that.
Updated, by the way, in the documentation, just so everybody knows. I just pulled this one because it was simpler and I didn't want to overwhelm people. But this was definitely an older one
that's not on you, that's on us. Yeah, but that's the diagram. A place we should dig into, by the way, is this column stats. And people will see this in the demo, but we have a place where you can show the profile of a table or a column, and that's honestly like always been a little tricky because it's expensive to compute those stats, and many times data warehousing systems have those stats automatically, and we should be able to leverage those stats. So I would love to learn what Trino has here, and then have integrations where we just power those stats directly from Trino instead of having to compute them ourselves.
Yeah, that's okay. So call outs, the beginning of the call outs that we have today, this is something that, we're looking into now, and we'll get into this a little more as we kind of talk through the demo. As you can see, my computer's a little laggy with this stuff, so I may not be able to do the demo live today, but I am going to do a recording and basically embed this at some point. And the main thing that I when talking from Trino standpoint is like we pulled data from the metadata, and so that's actually coming from a Hive metastore. So I think the contributions here would actually be coming in from the Hive metastore, at least when we're talking about the Hive connector. There's also Iceberg connector, but all the other ones would actually be, so the way I envision it is like the only times you're really having a Trino specific type of connection would actually be when you're querying the views. And I think we've already seen this. There's a Presto view, one that kind of pulls out the views from Presto. We would also need to write one for a Trino view that would pull out the Trino view tables. And then everything else would be coming from Hive or Iceberg. And that would be the ones that would be primarily based around Trino. The rest, that Trino connects to, if you were talking like to MySQL, that one you're already going to, Trino may connect to MySQL, but it doesn't actually maintain those stats or anything like that. I know you know this, Mark, but I'm just wanting to kind of relay this for anybody who's thinking about, how to, if I'm trying to apply this across my data set, is this going to be something that I just plug into just Trino? And I would argue that you want to just basically connect Amundsen and do all of the scraping individually to all of your distinct data sources, and then you're going to like for instance, if you had a Trino connected to MySQL, you're going to not try to think about like pulling any type of like information schema or anything through Trino. You're actually going to want to go directly to the MySQL source. So I wanted to make that distinction clear. And so what's left is you just have a Hive metastore, and eventually I think we'll have to also contribute something for Iceberg from our standpoint. Having both of those, being able to pull that in, and for Iceberg, there's a whole bunch of stats that are nested within the actual data structure itself that is kind of stored in the file storage and somewhat in the metadata layer. But going back to the kind of example that we're all very kind of clear around is more of the Hive metadata model. And that one has a lot of stats built in there, the same way with Glue. And I think like that's, there's column level stats, there is table level stats, and there's also, I think, Manfred could probably help me out here, but I thought there was also some based on aggregations as well. But
there's stats like column.
Oh no, Manfred, I think we lost him for a second.
Yeah.
Level and table level stats do like null. I think I'm back.
Yeah, you're back now.
Okay, it's really weird. I have terrible internet connection for some reason. No, so the stats include like distribution of like null values and like other statistics. It's just
definitely.
column and table stats.
Yeah, those ones definitely help out too. How many null values do you have in this column, and this kind of this piece is help here. So my point here in bringing all of this up is, definitely as part of anybody who's interested, just reach out to me or Manfred. This is definitely something we want to start looking at investing into from the community side, and there's a lot to be done here. So we'll make a couple call outs there. I wanted to feature a couple of these resources that'll be here in the show notes that take you to the docs, the GitHub, YouTube, and Slack channel. Definitely, Mark, you hold a lot of these office hours. I joined one just a while back, and you guys record all of them too, and put it on your YouTube. So anybody who's looking to break into Amundsen, like you're doing a really good job at trying to just bootstrap and make sure that you're recording and keeping all of the resources readily available so that anybody can kind of tap in and use them where they need to. So
yeah, for sure. And if we have the time, I'd love to, I know you can show the demo, but I'd love to dig in 5 minutes and show a quick demo of this thing as to what that looks like for our users, so people can kind of like crystallize this in their head instead of just
I think that would be superb.
Yeah, what we could do, I don't know, it's like, again, things are going super laggy, and I don't know if this is StreamYard or if this is like potentially some other weird issue going on possibly my end, but I will say, let's make a video. I'm going to make a video of my demo, and then if you want to also contribute a demo, Mark, I think that'll be super good. We'll embed those into the show notes, so you'll have your version, and I'll also do the demo. What we have time for still, though, and I wanted to jump into this because I feel like this concept has been coming up a lot, and Amundsen and as well as Trino kind of gets pulled into this, and this is this data mesh concept. So. So this has been, I call it a architecture philosophy, and yes, a buzzword. So it is very buzzy at this time right now. People are talking about it just to talk about it. Got a lot of exec levels that are just kind of saying it, talking about it without knowing what they're talking about. And nobody really knows what they're talking about. That's kind of the point here. I think that it's a base set of philosophies and actually a base set of principles that we've laid out here. These 4 principles created by Zhamak Dehghani. I didn't know if I said her last name right, but she does. She was the creator of this. She's kind of a consultant at ThoughtWorks, and she came up with this as kind of an answer to a lot of the issues that we've been having trying to centralize all of our data, into either a data warehouse or a data lake, and all the issues that come along with that. And her approach is trying to kind of keep things decentralized, try to follow somewhat of a mirror to what we do with the service mesh. And the same way that we have like in these Kubernetes bits where we have configuration that kind of tells you how things need to get run. And how to scale it out and descale it and do all the things kind of automatically. And this will be held and maintained by a particular team that is following some sort of domain. So let's say they're doing a shopping cart or a ETA in Mark's case, right, for Lyft. You have an ETA team that's handling that domain. They have a particular part of their applications that are being run by some service mesh that they define and they own. In the same way, we're trying to draw a parallel with that using this concept called data mesh, and basically have a parallel set of data ownership. And so you're taking that kind of centralized big data team and trying to decentralize, kind of data members to those teams, and now you'll be essentially giving that power over the data as a product to those teams. So how do you support that and actually do that across a company? And there's these kind of 4 principles in terms of how to create an architecture that will also kind of help the social political structures that have to also follow that there. And so the 4 things she lays out is domain-oriented decentralized data ownership and architecture. That's a lot, but I would say to make that easier, the decentralized data ownership part I would say is kind of falling under Amundsen's part, kind of showing, who owns a particular product or a particular set of data. And then, the decentralized architecture part is kind of where Trino comes in, where we're decentralizing the access and basically saying like, okay, you have your MySQL database here, you have your NoSQL database here, you have a Snowflake data warehouse over here. And that's fine. You do whatever you need to do within your domain to make you successful. And then we're going to have the central point of access called Trino, and we're going to meet you where you're at without you having to move data around or make extra copies so that we can make that happen. So that's kind of fulfilling that first tenet. I'm going to pause there, and I want to get Mark's reaction to kind of, do you think that kind of aligns? How do you think Amundsen fits into that first principle?
Yeah, totally. Aligns in my worldview. Amundsen and Stemma both fit in the ownership worldview. I think the way I see it is like you need to provide, there's actually an organizational change in sort of practice change, but then you need to provide tools to these owners to do what's expected from them, right? Yeah. One is the architecture where Trino fits in. Another one is a place where you can actually go put in information around ownership and manage the data that you own, right? And that place is Amundsen/Stemma.
Yeah. Yeah. So I think that's really kind of, reason why we're bringing this up now is I think because Trino and Amundsen, we don't make up the entire tool set here, and I'm going to talk about that in the last bullet point. We don't make up the entire tool set that you would need to realize a data mesh, but I think we're very solid components of what this would be. And so I'll talk about the next one, this data as a product. This one is trying to kind of provide the capability for when you have these domains. So again, going back to Mark's example of the ETA people, they own ETA, and so if anybody else needs to have ETA, they need to have a place where, again, we were talking about there's like 200 versions of ETA out there in the abyss. How do I actually find out which one's the one that's coming from the ETA team and who's owning it and taking care of that? So it's up to the ETA to take ownership of that data, not only just the service layer that sits above it, but the data itself. And how do I, give them the capabilities to actually expose that? And I think this is really where Amundsen also can come in. Again, it's a piece to that data as a product. It's not the whole thing. But you basically make the index or the human aspect where I can find that piece of information to dig on that and understand where that data is coming from and where it sits. But data as a product can also include pieces like, how do I actually make the standards around that product and the APIs around that product? And that's neither Amundsen nor Trino, really, other than Trino may be able, you could say SQL is that, but I think there's a little more to that one. Self-service data.
Can I pile on to that a little bit?
Sure, go for it.
I also want to say, as a product owner, you usually, like, think of a product that you own, let's say a website. Things that you care about is like who uses the website, how much traffic it's getting, all that stuff. When you build a data set as a product, you need to know that information as well, like who queries it, how often, if I'm going to have to modify it, who do I notify, in what ways are they querying it, so on and so forth. So that's also a key component of data as a product. Yeah,
and this is all things that, again, can come into with Amundsen as well. You can essentially put, when you put that, we'll show this in the demo later on. Unfortunately, I'll have to keep you guys guessing and waiting for this live view just because of this delays in our in the stream. But there is a point where you can actually assign, who owns the list of people who own the data, and then you can also have people that are get a list of who's actually using that data, and that's also kind of very, very useful, and how frequently that data is being used. All that's kind of getting exposed through the Amundsen AI, and that kind of helps out from that product standpoint. So very good point. Self-service data infrastructure as a platform. Again, this is where I feel like this is where Trino kind of comes in. Is everybody's going to have their own specific data solutions and data platforms, and that they're going to use for their own particular domain needs. And so Trino is there to essentially expose a single source to the analyst and basically be there as a way for anybody who's on one of those domain teams to basically plug into something like Trino and expose it through that SQL API. It's a standardized piece that everybody pretty much across any org will know, and it makes it to where everything becomes accessible because you don't need to know a million different query languages. You don't need to know where everything is how to connect to everything. It's already done there for you in that self-service kind of data infrastructure. And then, the federated computational governance, this I would say, is not Trino really much at all. This really comes down to a little bit of Amundsen. I think is, you can put some of the discussions and conversations. This is a lot of a human element too, by the way, but this can be, Amundsen can serve utility in this bullet point, because you then are able to facilitate the conversations and actually have down in writing, a kind of a map of your org at that point, your data org. And so Amundsen is kind of a key tool to get this thing started. But I think there's a lot of tools that just don't exist on the market today, honestly, to realize the full extent of that federated computational governance. Mark, I'll let you chime in on that one if you have anything to say.
Yeah, I would agree with that. I also think there is a perspective here around data discovery products that you should have conversation in the data discovery product and make it searchable and discoverable later. What I've learned at Lyft, there's a channel called Analytics Questions, where people come to questions that usually cross domains from a data mesh perspective, right? And in my initial version of Amundsen, I pushed these people to have these conversations in the data discovery product, right, in Amundsen. Yeah. And I learned the hard way that it's hard to change people's behavior, right? And it's better to meet them where they are. And so one of the things that I learned is that you should link the conversations that are happening in existing places to the extent where they're happening in writing into the product, instead of forcing people to change their behavior in the product. And that's like one thing that, for example, Stemma does differently, is that we have a Slack integration where a Slack bot connects conversations that are happening in Slack that are related to data sets to the data sets, instead of forcing those conversations to happen on the data catalog.
That's fair enough. Yeah, it's hard to, the human element is kind of the tricky part, and that's what the Amundsen and data discovery in general is getting into. It's like, it's the same issues that we had years ago when we were figuring out UI and human interaction, with computers. It's like a similar type of problem, but sitting on top of like, how do we get different teams that have data that needs to work together? How do we get them to agree on things? How do we, break down political issues that fall in between that? And sometimes, Amundsen kind of is a utility, it serves utility kind of to help make that progress, but it's also just like, it can't do everything. It's the same way that Trino can't do everything. It really, Trino kind of takes the whole human element out of it. It's like saving a lot of engineers' time and energy on pipelines, right? Amundsen goes a little higher and tries to solve a little bit of those problems, or at least facilitate the capabilities to have those conversations, but they can't have those conversations for you, and forcing people to kind of go outside of their typical norm of using the tools that they're used to facilitate conversations or do those things. It's just, you're going to get partial amounts of the data. Some people will migrate to the tool, others won't. And so at the end of the day, kind of taking the same approach that Zhamak is taking with data mesh, you have to just let the communications and let this stuff happen where it happens, and then centralize it I was to say it's a priori. No, it needs to be a posteriori. I can't remember the Latin word for it.
That's a word now.
Yeah, exactly. A posteriori. Anyways, let's go on. Before, I know you have a hard stop here in like 3 minutes. So tell us a little bit about what Stemma does, how Stemma, Stemma is, to me, the enterprise version of Amundsen, and I don't know much more about it than that. Can you tell us about like, what Stemma is offering and kind of, the vision and what you're all building over there?
Yeah, totally. So yeah, Stemma provides a managed data catalog. There are 3 things that have been inspired by the creation of Amundsen and seeing it develop and evolve that are a core part of Stemma. The first one is that in order to get a lot of rich metadata and power data discovery and data catalog, automated data catalog, you need to have a lot of intelligence and automation. This intelligence is like this linking of Slack conversations to the data catalog. It's intelligence around linking the most common join and filter conditions that are happening on the data set, how it commonly gets used. It's around parsing out the lineage and showing like what data flows from what dashboards are built on top of it. So Stemma provides all that automation and integration out of the box, right? And so the richness of metadata you get with Stemma is a lot higher. So the time to value in a user using it, the time to value in actually setting the data catalog up is all much shorter because Stemma takes care of all that. The last thing the Stemma adds is that there's a lot of organizational, operational work that needs to happen in order to make sure that the catalog is adopted and used within various domains and the functions of the business. And so some of that is product work and embedding it in the various systems and places that the organization already has, and some of that is working with users within the company, and Stemma works with the users to make sure it gets developed. So to summarize, there's a managed offering of a data catalog, which has a lot of automation built in, so we can power rich metadata and reduce the time to value to actually finding data and trusting data for the users within the company.
Cool. And for those just listening in, this will be in the show notes anyways, but just go to stemma.ai to learn more about that. That's where the Stemma's website is. Well, Mark, I'm going to take over your PR of the week because I think we're out of time for you. Thank you so much for joining us, and we're going to continue on for the rest of the show. Anything else you wanted to say before you take off?
No, my pleasure. As you're all in your data journey, whether it's related to Stemma, Amundsen, or unrelated, let me know how I can help. join the Amundsen community. Check out Stemma, stemma.ai. Thank you for having me on the show.
Great. Thanks so much for being around. Thanks. Have a good one. All right. Well, with that, let's go ahead and move on to wait. I gotta go. The PR of the week.
Record that. What's the PR today, Brian?
So the PR today, this is actually what I wanted to cover with Mark here, but unfortunately, he had to jump off at the right time. So this is actually a contribution to the Amundsen project. They do things in kind of a couple things I think in kind of commits. They do it slightly bit differently than we do it on the Trino side. So this is a commit of the week, but it is, I think, actually kind of a how they manage their encapsulation of the tickets that they do. So
I think it's a PR. If you click on the number 25 there, that's what it was.
If you look at, so I thought this was Index Presto Views, but that's actually the name, and it's this giant kind of So that's why I was wanting to go to this particular PR, but it includes a couple things. So this commit in particular is adding in what they call the Presto View metadata extractor. And so this was kind of what I was alluding to before. If let's just forget about all the other sources other than the Hive metadata source. So this is primarily the main focus of in terms of the connectors that people care to pull from Trino. They're looking to get the views. And again, if you're not familiar with what's a Trino view versus what's like Hive views and things like that, definitely take a look at episode 18. We talk about views a lot there. So the main reason why you want to pull data directly from basically Presto or Trino is that you want to actually pull out a view type rather than pulling out the Hive Metastore tables. If you want to actually pull out the concrete tables that underlie the actual the Hive connector, you actually want to use they already have a Hive metadata extractor, and I have that linked as well here a little further down. I don't know if it was down in the demo, or let me see if I can find it here. So I have it linked here. You can actually look at this extractor that they have. Remember, extractor is the first step that is used in those jobs, in the jobs for Amundsen. And it is basically the piece that just pulls out the kind of metadata and schema information. So it makes sense that we're actually pulling all of the metadata out of the Hive, like the Hive Metastore, right? Because that's primarily, in terms of like, if you think about the Trino database, is primarily the Hive connector connecting to the Hive Metastore and storing it onto your data lake or to HDFS. So what this PR did was it's actually concerned about, okay, we're getting the solid tables from the Hive Metastore extractor. Now we need to actually pull the views out. We want to be able to also see views that are sitting in there. And so this was a one that was added at this particular extractor. It's called Presto View Metadata Extractor, but it essentially still also works for Trino because the views that we pull out of the syntax that we use still on the Trino side in the Metastore itself also still uses Presto View versus Trino View. That's still something that to be updated, and it's still something that we have there so that we're backwards compatible anyways. So basically this will still work if you run this directly on Trino. It'll just show you whenever you pull it into Amundsen, it would show you a Presto logo whenever you see the Presto view. So we want to actually, I have a call to action for those that are interested in contributing to Amundsen. And I will be doing a video on like kind of how to set a lot of this stuff up. But I think that I want to do a quick call to action to anybody that wants to contribute just the Trino images. We can actually get a similar job like this that would pull out a Trino view. And instead of showing Presto, it would actually show the Trino branding and everything like that. And then the step after that would be, we could start building out a lot of that stuff that Mark was talking about before, which was saying like, how do we pull out the extra column statistics and things like that could actually really help out enrich the tables and enrich the information that could give more context to, oh, if I query this table, or if I want to talk to this table, it's partitioned on this column, or if I query this table, it's it has the statistics are kind of skewed in this particular direction, so I want to be careful how I query this particular thing. And that's really useful information to know from an analyst perspective. Sometimes maybe they even just have those questions off the bat. How many nulls are in this column, like you were saying before, Manfred? So these are kind of ways that we can kind of start to think about contributing to Amundsen. So please do reach out to me if you're interested in that. I do think that this is going to be a pretty cool area that we should be investing in, especially as Amundsen starts growing, and we want to start kind of enabling our community to utilize data catalogs like this. Final thing I'll say about this contribution, it's a really good one to kind of get your feet wet with. Understanding how to set up these extractors. It's a little bit of Python code, but if you start to compare this with a couple of the other extractors, you see that pretty much like the whole part that ingests the data into Elasticsearch and into Neo4j is pretty much standard. You can customize it, of course, if you want to something else, but if you just leave it the way it is, the only thing you really ever have to update is the extractor part. And we can go into that in a little more in some videos that I will cover on Amundsen later on. So
go later down the track, I guess we can expand that to get like iceberg views and stuff out of Trino and stuff like that.
That's another
materialized views on iceberg and stuff.
Yeah, they currently have no support for iceberg extractor or anything like that. So that's definitely another area if anybody's interested in doing contributions there. I'm not going to do the fancy intro for the demo, because really I'm just going to be talking a little bit through the steps, and then I'm going to actually do a video afterwards and post this, right? So the basic idea of the demo, this is already hosted. So once I get these notes up, I already have on my Trino Getting Started page a new folder called Amundsen. You can go in there, and I already have a Docker Compose set up that will pull up all of the Amundsen architecture alongside with Trino and MinIO. And then basically, these are steps that I pulled from the Amundsen Getting Started portion. What this does is this pulls all the Python requirements. So you have to have Python 3 to run all of these. And again, if you're running like this on Airflow and stuff like that, your Airflow would already have a lot of these libraries pre-installed. But if you're just running the random script yourself, then you just have to make sure you install all these requirements. And so you basically go through this step here to do the pull the Amundsen repository, build out the Python requirements and the Python dependencies here, and then you'll go and actually create the Trino tables. And then once you've actually created the Trino tables in MinIO, you'll then move back to the Amundsen directory, run the script that I have in there underneath the assets folder. And again, I can, no, I'm not going to show this right now, but underneath the assets scripts folder, I actually created my own loader, which is the last part of the ETL job. And essentially, when the loader runs, it points to the Hive Metastore extractor and tells the Hive Metastore extractor to pull the data out and load it into Amundsen. And then once that script runs, we're then able to verify that that data exists in Neo4j as well as Elasticsearch, and then you can actually see it sitting up there on the Amundsen UI itself. Again, check back in here. I'll blast this on social afterwards whenever I get this video completed, so that you can actually see all this in action. But unfortunately, due to the lag in the stream today, we won't be able to get to that. And so.
As part of the setup, you're basically running Neo4j and Elasticsearch and Amundsen and all of that stack.
Yeah, it's a pretty heavy. So one note of caution, right? Yeah, note of caution. Make sure you have at least like 3 to 4 gig when you're of memory when you're running this in Docker, and try not to have too many other things running. It is it's so all the images considered. It's just for Trino itself, you have MinIO running, you have Trino running, you have Hive Metastore service running, and you have MariaDB running for your Hive Metastore. That's 4. And then you have the for Amundsen side, you have Neo4j, you have Elasticsearch, you have the front end service, metadata service, and the front end service, metadata service. The there's another service there that I can't think of right now. I think there's also a 4. So there's about 5. I think there's 5. So there's 5 for Amundsen, and then 4 for so basically you have nine little containers running all on this, and they're a little memory hungry for quite a bit of it. So anyways, when you run this, it runs very well. You just have to make sure that you have sufficient memory. And even in the Amundsen getting started files, they do have a tale of caution about that memory stuff there. So
is Amundsen all written in Python then, like even the UI and those kind of things? Do you know?
Yeah, a lot of it is Python. I wouldn't say it's exclusively Python. I can't talk for every service that they do all of it in Python, but all of the interaction from the developer perspective, the ETL and everything up to, I'm not even sure, possibly, I didn't look at the DAGs myself. I did see that they were there, but almost everything that you'll interact with on Amundsen, if you're developing out your own ETL job, is going to be all done in Python. And then, so that's the typical thing. So you do have to have a bit of a background in Python if you're, I'm not a Python guy either. I'll point that out. Like, it's not so incredibly hard. I think the ramp up time will take you about a couple days, maybe, again, depending on how much time you have to spend on this. I'm not going to put an exact time. It'll vary for each person depending on their background, but it'll take you a bit of time to ramp up on the framework and understanding that ETL setup. But once you've done that overall ETL setup, and get to understand how they define all those pieces, you just need to look across like 1 or 2 or 3. I think it starts to click. Oh, okay, this is how this is set up, and you don't have to be like Python whiz to be.
It just shows also. It's interesting. Like Python is definitely a very dominant language in the whole AI and data science kind of world. So anyone that's in that ecosystem will have some sort of passing familiarity with it already, and it is pretty easy to read, at least anyway. So it's cool.
Yeah, I use Python constantly for consumption, like for consuming APIs and stuff like that. It's so the requests library they have is just so simple and so fun. But anyways, okay, so. The last little bit, I promise you I will get you a video before the end of the day tomorrow, and then I will blast it on social and you guys can all come check that out. Let's move on to the question of the week. All right, so the question of the week is we actually got this 2 times last week from 2 different people, and so and I've seen it. I searched it back when I start to see these questions come in. I searched back in earlier chats, and it's been a fairly common question. So the question is, and this is like a pretty dominant theme for various plugins in general, but can I add a UDF? And for those that aren't familiar with what UDF means, it's a user-defined function. And so I have the link in the show notes to the documentation to building out these user-defined functions in Trino. But the way that you typically do this is you'll extend a plugin framework that sits in part of our SPI, and then that has to get basically compiled to create the version of Trino that will now contain your UDF. And so,
well, you typically don't compile the whole of Trino. You compile the
plugin.
That plugin, which makes a jar file, and then you have to deploy that jar into your server.
Yep. And when you deploy that jar, you have to, in order for Trino to recognize it, you have to currently restart in order for it to pick up that new plugin.
That makes sense, right? Like, I mean, Trino as an architecture is a Java application, and it's a distributed application. So when you have a user-defined function and Trino in a distributed fashion needs to process that everywhere? Well, it needs to know about that function on all the workers, right? It can't just like, because Trino schedules things to run wherever, like somewhere on a worker. So you can't have some workers that know what the function is and others not. So they all need to know about it, and the coordinator needs to know about it. And so, and in order to restart, the reason you need to restart is because in Java, the default is that jar files and like code basically gets loaded at startup time and then just sits there, right? Like you don't on the fly load more stuff, right? So that's why you need to restart.
Yeah, and that makes sense. I do think there is. So I remember seeing a response from David. I think it was one of the more recent ones, was that there has been work to try to make that that workable. Like, so at least so you can put out, like, the idea would be, the ideal thing would be to you distribute the plugins to all the workers and everything. Still, you're going to have to do that no matter what. But the question would be, would we be able to have a dynamic way for basically Trino to occasionally run something, or maybe you could even prompt something from the coordinator to tell the workers or something to, hey, check your
like if you use, like, say for example, the Starburst enterprise deployment in our Helm charts, or even also probably the Trino Helm charts over time, you can do a rolling restart of all the workers, right? So literally the cluster keeps on running, but the individual workers reboot and reload. The other aspect, that's something that I think David was also alluding to, is the user-defined functions are currently written in Java, but Java has support for like what's called the Java scripting API and other methods where you can actually, in a running Java application, define scripts, and that could be an entry point where you can literally sort of like write that function, that user-defined function, and it becomes sort of something that's like just interpreted on the fly. And then that would not require a restart. So there's work to be done to potentially make that happen, but currently you have to restart.
Yeah. So it makes sense why it's there. It'll be definitely something that, over time, I think is going to be one of those things that get resolved. I think in general too, like, there's a couple other things that, like, when you add catalogs, that's been another very highly requested feature, is dynamic adding of catalogs and things like that. And so, without having to restart and do that kind of stuff. So I think those things are definitely on the roadmap. It's just like, and not like on the near frame roadmap, but I think it's things that we consider that, are things that are worthwhile, that are going to be worked on at some point. But it's just when somebody is actually going to work on that, or if we are able to, as terms of the core maintainers, and kind of core contributors start to decide, hey, this is something we should really be focusing on. That's kind of another question, and hard to determine 100%, because again, always plenty of things to do in open source world, right? So
also, I think what you have to keep in mind, that it's a very typical question to ask by a newbie that just wants to get started. But like in the real world, you don't write new user-defined functions that often, and you don't add catalogs that often. It's more like an occasional thing every, like, whatever, a couple of weeks, if that, right? So then the like urgency to like be restarting that straight away, like having to restart, is not really something that's not that important in the real world. So that's why there's a lot of noise around it, but in reality, it's probably not as important. So.
Not in production cases, no. And so that is another thing to keep in mind. But it is, from a playing around standpoint, even, just getting somebody ramped up and they get to play it in the sandbox and stuff like that. It would be nice to have that kind of capability, but it will come. I think it'll come, and these things pop up almost sometimes mysteriously, like, wait, oh my God, So that's why release time is always a fun time. So
exactly.
Cool. Well, Manfred, do you have anything else you want to cover before we hop off for the day?
I'm really looking forward to that demo. Maybe Mark was also saying he might just do a little demo as well. It'll be interesting to see Amundsen. But for those of you that want to like sort of jump the gun and like learn more, I definitely urge you to check out the Amundsen website as well as the STEM AI. They both look very informative and useful. So there's a lot there. So you should be able to get rolling on your own even. But both Brian and Mark's demos will also be very welcome. And look out for them on Slack, I'm guessing, right?
Slack. I'll tweet it. I'll throw it on LinkedIn. Anything, anywhere you are, I will be blobbing about it, because I think this is something I've been wanting to get onto for a long time, and now that I have the demo, I just really am annoyed that the streaming was like so tacky today, because I actually worked pretty hard last night to get this thing rolling, but I'll get this out really quick, and just look forward to it, and I'll really kind of go over how to actually get involved in this project as well, if for those hopefully that are interested.
Yeah, that sounds good.
Awesome.
Looking forward to it.
All right. Well, see you all in 2 weeks.
Bye.
Music for the show is from the Mega Man 6 gameplay album by Krzysztof Słowikowski. Don't forget to give us a star on the Trino repository at github.com/TrinoDB/Trino. And for more information on future shows and to find show notes, check out trino.io/broadcast.